Mark Pallen, I'm the director of this project, Climb Big Data. That basically means I'm the one that writes grant proposals and gives the warm-up talk. I'm not the one that has all the technical expertise. There are others in the room that are going to do that. In particular, Nick is going to. I'm his warm-up artist for him. But I'll just give you a brief introduction to what the project's about and where it's come from. And I put this up particularly because Nick plays a game of conference bingo where he likes to tick off things that happen at every conference. You can go and have a look at the Microbiology Society conference. Someone will put this slide up because it's one of the things that always gets put up there. But it shows you basically the cost of sequencing has gone down dramatically. The paradox, as George Church in Harvard pointed out, is that it doesn't mean that we are spending less money on sequencing or spending the same amount of money to get more sequence. We're actually just doing more and more sequencing all the time. And this creates the problem of what we might call drinking from a fire hose, that trying to actually, if you want to do any kind of comprehensive analysis of anything, you're just grappling with big data, and it gets worse year on year. So a few years ago, in fact, Tom, who's just about to sit down, was the one that said we should be using cloud computing because this is a more efficient way of using resource. So instead of each person buying their own server in each department in every university in the land, why not use a cloud computing infrastructure where you have a number of virtual machines running over a program called OpenStack. And the arguments for doing this were twofold. One was from our point of view in providing a service, it made it much more cost effective because we could actually make sure that the hardware was being used more effectively all the time, provide better value for money. But from the user's point of view, it meant that you could access a virtual machine that had been pre-configured for your usage, so that you took away all the hassle of you actually installing operating systems, dependencies, all that kind of stuff. Also provided a mechanism for sharing data, sharing pipelines, making it much easier to standardize the kind of research you're doing, make it more reproducible, just takes away effort from people. And a key feature when you're trying to run training for undergraduates, PhD students, postdocs, you can actually have a standardized offering, so everyone is getting the same experience in the room, rather than everyone coming along with their own different setup. So we ran a project called Climb for 6-7 years, and then a few years ago we needed to come up with a successor project to Climb Big Data. And this is the problem we're aiming to address here, is how do we actually allow microbiologists across the UK to exploit large genomics data sets, and how do they get the resources and the tools and the expertise to do that. And so we have this 5-year initiative to deliver this cutting-edge, scalable dynamics bioinformatics platform. The plan is to support academic research, so microbiologists working in universities and research institutes, but we're also being very keen to build an interface with frontline government agencies. So Nick works part of his time for UKHSA, Tom works with Public Health Wales, and we've maintained that interface all the way through this project to great mutual benefit, in fact, from both sides of that. This is just a summary slide that was put together for the proposal that went in, and it summarizes the various topics that we work under. Community engagement, running training, hackathons, workshops and so forth. We did an awful lot of this, particularly Nick and Tom did a lot of these workshops during the COVID pandemic, basically building and maintaining not just the national capability, but internationally as well to deal with the pandemic. We've also invested in infrastructure, so we've got lots more graphical processing units now and enhanced storage. We have added to our cloud computing infrastructure, refreshed the hardware, and also got new warranties and so forth, so that's keeping the show on the road. We're also keen on tools and integration, and looking at things like containers and providing software, ways to install it, and we'll come into the details of that later. And it's a collaboration between a number of universities, the Quadram Institute, Research Institute, and I put COG UK in the corner there just to ram home the fact that we did interface with COG UK and work with COG UK, and the Climb big data infrastructure was used to serve all the COVID genomes coming out of the UK to the public and to the rest of the world. So it played a key role there, and that worked again in both our benefits, in that we've now inherited some hardware from COG UK because of those efforts. Here's the team in the round. I'm not going to go through each person and introduce them and whatever. Many of them are in the room here. One of the key things that have given us success is that people have worked together in harmony. They've often gone beyond what their job description says. There's been a lot of knock for knock and informal arrangements. But together we've actually created some great things. And I always take this opportunity in public to say thank you to the whole team, because it is astonishing what we've achieved in these last few years. And, I mean, it did make a big difference during the COVID pandemic. So just my last slide now, just to say, well, where have we got to? Since we started the new Climb Big Data project, we've improved our user support in various ways, shown there a new ticketing system, a BRIN interface, improved security and so forth. We've moved towards self-sustainability, and this was something that the MRC said. When we went back to them for a second round of funding, they said, you can't keep coming back every few years, so you have to start raising the funding to run your show from your users. And so we now have a costing model in place where we can accept money from people, we can tell them how much it's going to cost and so forth, and we have several lines of income. We've also enhanced our infrastructure, as I mentioned. We'll talk about S3 and GPUs. Nick's going to tell you more about that. And the key point of today is that we're moving to a new usage model. So the problem we used to have was that people would fire up a VM, a virtual machine, and they would use it to do some analysis. And in so doing, they would take up some of the resource that we had available, even things like as simple as occupying an IP address. But they'd often forget to turn it off when they'd stop using it. And so we'd ended up with lots of stuff just sitting there fairly idle. And so we've moved to a more efficient system now, where we're using these so-called Jupyter notebook servers, which are much more ephemeral. They pop up and they use resource as it's needed, but then they give the resource back to the center when they're turned off. And these come with a terminal, various notebooks, Python and R notebooks, S3 buckets. And for those who are interested, there's a lady at the back there who is interested, we have GPU notebook servers, which will provide all the resource you need for machine learning or for a running beast or whatever you want to do. As I say, I'm just a warm-up man. I'm going to stop there. Has anyone got any questions at this stage or any comments to make? No? I'm going to pass over to you now then, Nick.